All right, using your graphing calculator, let's go ahead and enter this data. All right, one thing you want to do before you enter the data is, if you'll notice, my X values are years 1985 through 1989. It's a good idea to create that first date as your initial value. In other words, let's graph this as years since 1985. That way my 1985 becomes 0 and I have my initial value. It makes it much easier. And also, those are mighty big numbers for your calculator. 1,985 is a big number for it to handle. So we're going to call 1985 0. So 86 is 1 year since 85, etc. And I think I got carried away here, so let me delete one. All right, and then enter your data into L2. So 27.6. All right, once you get your data entered, go ahead and graph it. I've got to turn my stat plot on. Everything else looks good. I'm going to zoom down here to number 9 stat. That'll set the window for me. I don't see my graph. That's not good. Well, let's set our window by hand then. All right, so -1, 5. Unless I didn't turn it on. And then my Y values were between 27.6 and 32.1. So we'll do 25 to 33, and we will graph. And hopefully something will happen. There it is. Okay, it didn't set the window. I must have hit something wrong. All right, so looking at our graph, we can see that we have an approximately linear set of data. That data falls into approximately a line. So now I'm thinking that I can run a linear equation for this. Now, I could try to do it by hand by simply attempting to draw a line through those points as best I can and then figuring out the slope. But the nice thing about the graphing calculators is that they will do it for you under what we call a regression equation. It'll write a linear regression equation for us. So let's go ahead and try to get the calculator to do that. So to get there, you need to hit Stat, over to Calc, and then you can see it's got a series of regression equations starting with number 4 and moving down, linear, quadratic, cubic, etc. We're looking for linear, so we're going to select number 4. Now, if at this point you hit Enter, you're going to see the equation and everything's going to be great. However, if you want to let the calculator do the work for you and go ahead and store that equation and then you can just immediately graph it, you can go through the following steps. And there are several ways to get there, but I'll show you the way I like to do it. If you'll select vars, which is variables, and then slide over to yvars, we're graphing a function, so number 1. Generally, I store everything in Y1 just because it's convenient, but it doesn't matter which place you choose to store it in. Enter, and then be sure you enter one more time, because right now your calculator is asking you, do you want me to run a linear regression? and then store it in Y1, and yes I do, so enter. It'll show you the equation, so A is your slope on the calculator, and B is that vertical axis intercept. So my new equation would be y equals 1.15x plus 27.7. The neat thing about what you just did, though, is if you look under y equals, there's the equation and it's already stored for you. All right, hit graph, and we'll see how well it fits. All right, looks like the equation fits quite nicely. All right, the line is fitting my points pretty well. Sometimes it won't go through any points, but this is what we call the line of best fit. The calculator has figured out where to place this line so it best fits these points, these particular points. Why do that? What's the point in going through all of this? Well, when we see data, we like to model it so that we can make predictions with that data set. So we're going to take a minute and we're going to make some predictions. This data set ran from 1985 to 1989. So we're going to predict, based on our line, what occurs in 1991. I'm going to show you one way to do it, but there are several ways on this calculator to get these answers. I'm going to use the table. I want to figure out what happened in 91. All right, remember you guys, we started with 85 as 0. So how many years past 85 is 91? Well, 6. So the number we're looking for is when x is 6. All right, so we're going to go first to our table set, which is right above window. This tells me where I want to start looking. Do I want to start looking at 0? Well, I got to get to 6. 0's okay. If I were trying to get to 200, I don't think I want to start looking at 0, so I would change that number. This one tells you by how much do you want to go up by. The delta table, I want to go up by 1, so that's suitable. I'm going to leave it right there. All right, so we're going to now look at the table, which is above the word graph. And it looks like when x is 6, let's go down here, the expenditures for the education budget would be $34.6 billion based on my graph, based on the line I just fit to those data points. So I can make predictions with this. If you'll notice, guys, take a look at the table and see how much your line says were expended in 1987. Okay, remember that's 2 years after 85. So what happened in 87? Well, it looks like according to your line of best fit, there were $30 billion in expenditures. Look back at the data set. Is that exactly the same as we had on our data set over here? Is that the same amount you had for your data set? Well, no. And rarely is it. Rarely do they come out exactly the same, but it should be around that figure. The real expenditures were $30.4 billion. Your line says approximately $30 billion. So this line of best fit is going to give you a good approximation of what's going on. All right, what we've just done is we have, down here and show it to you, we have made some predictions, and we've actually made 2 types of predictions. One type, or one way that we predicted, is through extrapolation. All right, extrapolation is a prediction that is made outside the data set. Your data set went from 85 to 89. We extrapolated to 91. That's outside, that's beyond 89. So when you extrapolate, you're going outside the data set. The other type, when we looked at what happened in 87, is called interpolation. You're looking inside the data set. I was looking between 85 and 89 to figure it out. Now, I want you to be cautious. When we use models to predict with, be aware that when you extrapolate, when you go beyond the data set, things get a little bit more iffy. Am I exact? Is this really what's going to happen 10 years from now? And when we use models to extrapolate way farther outside the data set, oftentimes they're not accurate. Okay? Interpolation is much more accurate because you're staying within the data set. All right, I've got one more problem for you guys to try on your own. If you'd like to stop at this point and try this problem, please do. See if you can find a model to fit it. Now, I want you to notice one thing before you do it, though. Take a look at your x values. Are they all increasing by the same amount? Okay, clearly not. So, will you be able to find first differences for this data set? Well, the answer is no. You can't do it because those x values aren't increasing by the same amount. So the only thing you're going to have to go on this time is graphing these to see whether or not a linear equation fits. So at this point, if you want to stop the video and try this out, please do. And then I'll show you the answers in just a second. Let me give you your questions. There you go. Okay. Oh, thank you. There we go. Take a look at your questions and see if you can answer each of these. I'll go back to the data set one more time. Your teacher should have copies of these questions. I thought that's right. All right, there's your data set. All right, now that you've had time to go through the problem, here are the solutions. Just take a look and see how you did, and good luck with all of your linear functions.